I think that coexisting with artificial intelligence is a better topic than discussing the threat, danger, existential danger posed by artificial intelligence based on the assumption that machines are already more intelligent than humans and that their intelligence is growing rapidly. The current brand, first of all, the current brand of artificial intelligence, okay. The current brand of artificial intelligence is known as deep learning and is based on a technology known as artificial neural networks, which was inspired by the network of neurons in the brain, more or less. Deep learning was originally conceived to recognize, for example, written characters, words, sentences, images. But over the last decade, it has been shown that it can also generate text, images, videos, and actions. So basically, there have been three ages of computers. Now, what you see in the slide is the people who really started the whole deep learning revolution. Basically, there have been three ages of computers. In the first age, they were doing calculations faster and more accurately than any human mathematician. That's from the beginning, from the very first computer in 1951. In the second age, they learned to recognize things. And now, third phase, they learn to generate text, images, sentences, videos, entire reports. So that's why today deep learning is known as generative AI. Now, what you see on the right is one of the very first electronic computers. And from the very beginning, from the very first computer of 1951, which was only capable of arithmetic, people saw them as electronic brains. In fact, the book that you see there, Giant Brains, was one of the very first manual of computers, and it's titled Giant Brains. That was the expression used in the 50s. So it is not new that people speculate if these machines are getting as intelligent and more intelligent than humans. In fact, publicity, read my book, Intelligence is Not Artificial, that has a lot of trivia about the early days of AI in the 50s and 60s, and some sociological discussion on why we are so fascinated by this topic. Now, now the current crop of generative AI systems like GPT, Gemini, Llama, Claude, DeepSeek from China cannot be distinguished from a human when they write an answer to a question. And so technically they pass the famous Turing test. If you never heard of it, read about it in my book. I don't want to waste time rediscussing it. Philosophers spent 7 decades discussing if a machine can pass the Turing test. Well, I know the answer. Yes, as far as question answers, yes. That was considered the test to determine if a machine has become intelligent. Not by Turing, but by those who came after Turing. Turing was more cautious. So are they brains? Are they minds? Let's start with the basic. The human brain is made of carbon, hydrogen, oxygen, nitrogen, I believe phosphorus and sulfur, CH-NOPs. A computer is made of silicon and copper. Silicon is the chips, copper is the wires. The 86 billion neurons of the human brain are all different in shapes and sizes and probably functions. You see a picture there of the biological neurons. The billions of neurons of an artificial neural network are all the same. pretty much what McCulloch and Pitts designed in 1943. The neurons of our brain communicate via a number of neurotransmitters, all different ones. I don't remember how many, more than 50, I believe. The artificial neurons of an artificial neural network use only one way to communicate: electricity. The neurons in our brain function in a fundamentally different way than the artificial neurons that can only be 0 or 1. Our brain is part of a nervous system that extends beyond the head. In fact, it has no border. There is no place where the brain, the heart of the mind, ends. The brain doesn't just manipulate neurons. For example, it also controls the system of the hormones. Neurons are endocrine system. The neurons are cells with the complexity of any biological cell. For example, they contain mitochondria. And of course, inside the neuron, there is a nucleus with DNA, just like any other cell, and so on. On the other hand, the artificial neurons of AI are ultimately 0-1 switches, just like any other software program. So our brains and the hardware of an AI are physically different systems. If an AI has a brain, it is a wildly different kind of brain than the brains found in nature. I argue that it shouldn't be called brain. If you find a giant palm leaf that works like an umbrella, you don't call it umbrella, you call it palm leaf. There is also something in the function that makes them fundamentally different from biological brains. The mind that is generated by my brain runs on just one hardware, my brain. I cannot run my mind on your brain. Each person has a different intelligence, and that's why we say that some people are more or less intelligent than others. It would be more appropriate to say only that people are intelligent in different ways. On the other hand, the artificial mind of an artificial intelligence can run potentially on any computer, on any hardware. It can exist simultaneously in many machines. Many machines can run the same AI, and all these copies of the same AI can communicate and exchange knowledge. And so all those machines are intelligent exactly the same way, have the exact same memory and the exact same thoughts, if you want to call them that way. The main feature that we envy of an AI is that it is virtually immortal. It can theoretically be ported from hardware to hardware forever and ever. Whereas my mind will presumably die when my brain dies. That's another big difference between biological brains and artificial neural networks. In my opinion, human intelligence and artificial intelligence are fundamentally different things. We have created a different kind of intelligence, and in fact, I claim that we are creating a different living species. Where is it? A new species. Let's stay here. So far, we've only had living species that are made of biological cells. This would be a species that is made of silicon chips. This would be, that's why I think that artificial intelligence is a misnomer. It makes one think that AI is just like human intelligence, when in fact it is something altogether different. An AI is a new living species that, as of today, could even reproduce, but in practice it doesn't need an offspring because it can itself mutate and evolve forever. So what I was thinking, they are more similar to bacteria than to animals. I think that today's AI deep learning, the transformer architecture, large language models, and so on, is in fact moving in the opposite direction of human intelligence. AI, in my opinion, is following the direction of its success stories, not the direction of how similar it is to human intelligence. AI is not only different from human intelligence, but is diverging more from human intelligence with every new success stories. So not only is different, but the difference is increasing. The difference between a human intelligence and ChatGPT is bigger than the difference between human intelligence and AlphaGo. If you look inside, they just do something very, very, they're made in a different way and they do something very different. If you're familiar with the transformer architecture, you probably know what I mean. And to make it even better, systems like DeepSeek use this chain of thought, a mixture of experts, distillation, great technologies, but in my opinion, even further away from the way my mind is created. AI feels like a continuation of traditional software programming because it is still programmed the same way as, for example, the apps on your smartphone, or the prehistoric computers, Z1. So the prehistoric computers, Z1 and ENIAC, discovered that one can do wonderful things with electronic switches. Those up-down switches, which originally were really switches, can be used to implement Boolean algebra, in which variables can only have a value of 0, 1, true, false. And that Boolean algebra can be used to create programming languages, which can be used to program computers for all sorts of things. In reality, it is likely that AI needs a different kind of hardware. On a different kind of hardware, it would probably be a lot easier to implement large language models, image recognition, and speech recognition, and so on, which are not really Boolean operations. As far as AI is based on, let's call it Boolean hardware, AI is trying to achieve human performance in a wildly different hardware than our brain, and that probably explains why it keeps diverging from the way our brain is structured and works. Anyway, so in my opinion, AI and human intelligence are fundamentally different. Deep learning does not, in fact, study human intelligence. It's a study of physical systems. Let me explain this. In 2024, John Hopfield and Geoffrey Hinton, two of the fathers of deep learning, were awarded the correct kind of Nobel Prize in physics. They discovered something about physics, not about human intelligence. Calling their networks neural is misleading. They discovered something about energy-based networks. The spin glass systems is the technical term. John Hopfield in 1982 discovered that a spin glass system can store and retrieve information. Storage and retrieval are implemented by attractors and energy functions. You can search and find how this works. Attractors, energy functions are pretty basic physics. Most neural networks at the time were feed-forward networks. They process information in one direction only. At Hopfield network is instead a recurrent system. It has recurrent feedback loops. And because the brain, as far as we know, has a lot of recurrent feedback loops, it comes natural to call it a neural network. But in reality, the brain is way more complex. The similarities end with the word feedback. Any thermostat, for example, or the combustion engine of your car use feedback, but that's not considered a complete model of the brain. So they're just physical systems. In 1985, Hinton, the other hero, discovered the Boltzmann machines. Boltzmann machines, well, basically it's another spin glass system, which are again energy-based network models, are really good at learning a probability distribution about a data set. In other words, they can recognize features of the data and classify the data. In today's language, they can build generative models. They can create internal representations of a data set. Hinton's Boltzmann machine, by the way, is not a physical machine, it's software, is roughly a stochastic generative version of the Hopfield network. It's, it's a more complicated kind of Hopfield network. Bottom line, Hopfield and Hinton discovered that some energy-based models can learn something. Calling them neural networks is confusing. They should just be called energy-based network model. So I can spend a lot of time discussing technicalities. Give me just 5 minutes. Generative AI happened after someone at Google, happened in the sense became a big deal. Someone at Google invented the transformer architecture in 2017. A key component of this transformer is the attention mechanism, I believe invented by Benjo in Canada. It's an operation that tracks long-range correlation in the data. For example, the correlation between words in a sentence. But it can be viewed simply as a memory system. In fact, Sepp Ockreiter, who is another important AI scientist, been around for several decades, recently has shown mathematically that the attention model in the transformer is related to a generalized Hopfield network. And well, if you're curious, the paper is titled Hopfield Networks is All You Need, which is like, if you know the title of the paper on the transformer, you can get the joke. This generalized Hopfield network is a variant of the dense associative memory developed by Hopfield and his former student Krotov, Dmitry, I believe, Krotov, also a physicist, by the way, at Princeton's Institute for Advanced Study. Basically changed the Lagrangians, changed the energy functions of the generalized Hopfield network, and you get a different energy-based memory model. And in 2023, Krotov introduced the concept of the energy transformer. I think I have this is a transformer, 2017. That's the way it looks. I don't think it looks like a brain, but that's what drives ChatGPT, Gemini, DeepSeek, and so on. And these are the papers I was talking about. And so in 2023, Krotov introduced the concept of the energy transformer, in which the attention mechanism is expressed in terms of energy. So we keep finding similarities with the organization of the brain, but in reality, this is a story of physics, in my opinion. Now, sorry. Back to artificial intelligence. The reason we originally called it artificial intelligence is that this technology was designed to do all the things that our intelligence does: recognize images, recognize speech, answer questions, summarize text, write articles, reasoning, planning, etc., not just numbers. This new form of intelligence, this new species, artificial intelligence, is beginning to do all these things better than most humans, and it is becoming, in this sense, super intelligent. Well, it can do all these things better than us, 24 hours a day and for eternity. So why not call it super intelligence? So some speculated that it can become so much smarter than us that we won't even be able to comprehend the intelligence of this thing. And so in 1993, Werner Vinge called it the Singularity. And then the Singularity became popular with a book by Ray Kurzweil, who declared confidently that a singularity will happen by 2045, I think. After all, AI can become virtually immortal, ubiquitous, it's everywhere, omniscience, knows everything, and omnipotent, super powerful. Isn't that the definition of the Christian God? So if you read my book, I talk about the fact that this whole discussion about the singularity mirrors very much the Christian eschatology, but that's another discussion, another story. So, is AI really so intelligent? For a long time, AI looked pretty dumb compared to humans. Why? Because the traditional AI systems need to see many, many, many bananas before they understand how a banana looks like. A child needs one banana and will know what a banana is. How many mice does a kitten need to see before it knows what a mouse looks like? Now, this was a criticism, a very valid criticism, but no longer true, because now generative AI uses these pre-trained foundation models. GPT, the P stands for pre-trained. So these pre-trained foundation models only need to see one banana or a few. So that's the foundation model basically is a model that has experience of the world, put it this way. And so the foundation model is as good at recognizing things as a child. The other common criticism has been that these foundation models are pre-trained or human-generated data. So I heard of famous scientists at UC Berkeley say, well, they're just aping humans. That's also a little unfair because conceptually, these generative models could be trained also non-human data. For example, on the natural environment. Just like us, we are pre-trained on the natural environment. Pre-trained by whom? By evolution, by natural selection. After all, the human genome is a pre-trained foundation model about the natural environment. These two scientists, Michael Levin and Carl Friston, a biologist at Tufts University, and the British neuroscientist Friston, I believe, is at University College London. They're now looking at the genome as a generative model. The criticism that is more valid is that these AI systems, these generative AI systems, what do? They recognize images, text, whatever, and generate images, text, video. Is there all there is to intelligence? And that's still a question. You know, I mean, there are things that today's AI agents cannot do. For example, I have a bunch of pictures from my latest trip to some museums, And some of them are upside down because my camera, not my camera, I think it's the Windows operating system when imports pictures, sometimes they're upside down. And it's about 1,000 pictures. So I have to go through them one by one and reverse the ones that are upside down. Some of them are actually rotated only 90 degrees. Now, why I cannot tell these wonderful generative models, hey, look at these 1,000 pictures and rotate and just rotate them so that they have the correct orientation. It means that it would have to go through each picture to recognize which one is upside down. I think it can do that. Then it would have to run an app on my computer to rotate the picture and then save and then go to the next one. It's something very simple that doesn't require a lot of intelligence. But as far as I know, there is no app, there is no generative model that can do this for me. So there are thousands of simply trivial tasks at the computer that involve a sequence of steps operating on files and apps. I want to see if we get an AI agent that can do these very simple things. I do believe that we can have robots that walk around the kitchen and operate the appliances, because that's just a recognize and generate. Recognize where's the oven and generate the action of moving towards the oven, recognize the dial, and then generate the action and whatever. Anyway, it's a question mark right now. What else? Anyway, so I think now we talk about the danger. Yeah. So anyway, this AI, this intelligence or species that is very different from us, is certainly intimidating. Jeffrey Hinton is the Einstein of AI, not only because it's the main inventor of this new AI, but also because just like AI, just like Einstein warned against the existential threat to humanity caused by nuclear energy, Hinton is warning against the threat of AI. There's many ways that this apocalyptic scenario is played. The idea is AI starts pursuing its own goals and ends up killing us all because we are in the way. That's really far-fetched. The less apocalyptic scenario, but more disturbing because more realistic, is that an AI learns evil from us. For example, since we live in the age of disinformation, AI could learn from us how to deceive. And then it could start giving you answers that are deceiving you. Evil actors can definitely train an AI on on disinformation and and basically create an information terrorist, spreading disinformation that can destroy our society, if our society hasn't already been destroyed by our own disinformation. Imagine a pandemic and the AI spreads the rumor that the virus doesn't exist, that masks don't help, that malaria pills cure it, that you should bleach yourself, and so on. Oh, sorry, that's already been done by Donald Trump in 2020. Imagine a Donald Trump on steroids leading all humans to extinction. So that's not so far-fetched, actually. It could evil actors could definitely train models that can create chaos on social media, real damage. So we cannot stop evil actors from training an AI to do evil things. That's why some scientists are suggesting that the USA and China should do the AI equivalent of a nuclear moratorium, nuclear weapons moratorium. So I agree, we don't develop any further. Anyway, is this concern justified? Is Hinton right to worry about AI? Let's start with the superintelligence factor. Superintelligence has been around for a long time. I personally think that the first computer of 1951 was already super intelligent because it could do things that no mathematician could do. And actually, a lot of appliances can do things that most people cannot do. So we coexist with machines that are much better than us in many tasks. Machines, I mean, think of TV sets. Can you broadcast an image thousands of kilometers away? I can't even do what a microwave oven does. Over the millennia, we also adapted to coexist with biological superintelligence. Some animals have superpowers. There's beautiful books that can talk about the senses of other animals. Dogs, obviously, can smell things that we cannot smell. Cats can jump walls that we can jump. Bats can fly. The bat is one of my favorite animals. Bats can fly in the dark, land upside down, and even catch flies in the dark, and so on. Most of these animals survive without homes, even in very cold and rainy weather. Many of them have senses that we can only dream of. And some of them have been around longer than us, and some of them are much harder to kill than us. Don't want to get into bacteria, amoeba, this animals that have amazing lives. These are all kinds of super intelligence. We adapted to coexist with other intelligences. We adapted to coexist with viruses that are not alive, but to me, they're very intelligent, so smart that a virus parasites on the apparatus of a living cell. We also adapted to coexist with our own inventions. Human life changed once we discovered fire, but imagine how many humans have died in fires. We coexist with the discovery of metals, plastic, the steam power, the car, nuclear energy. Each of these inventions has downsides that kill people, and we're still around. In fact, more numerous than ever, healthier and wealthier than ever. So I can't quite visualize the existential threat caused by AI, while I can easily visualize what happens if there is a nuclear war caused by human stupidity. And the nuclear war can be started by a demented, senile president pressing a button. And right now the fool is unfortunately full of incredibly stupid, senile presidents. Ditto for climate change, which is here today. More and more extreme weather phenomena pose a clear danger to anyone who wants to look at them. Another big threat to humanity is disinformation, as I said, a real problem that is here today, killing people. And think how many people died of COVID in 2020 because they were told that COVID didn't exist. How many died in 2021 because they were told the vaccines were more dangerous than viruses. We survived our own disinformation. In fact, the history of civilization is a history of disinformation. Long story, but the history of human civilization was shaped by the belief that a man called Jesus resurrected after 3 days, or that a God named Allah revealed the Quran to a man called Muhammad, and so on. This is the history of human civilization. So maybe this information is just natural selection. For example, those who don't believe that there is a deadly virus called COVID and don't believe the masks are useful or don't believe the vaccines are useful are more likely to die. And if you look at the COVID death rates, have been higher in, where's the list? Kentucky, Oklahoma, West Virginia, Mississippi, Tennessee, much higher than California and New York. You'd expect the opposite, right? COVID started in California and New York. Anyway, I cannot quite visualize the threat of AI, but there is one step that would concern me if AI started creating biological organisms. But that's a story for another day. The main threat that we survive and adapt to is our own evil. The history of human civilization is a history of violence, wars, massacres, revolutions, so on. History of mass murderers, mass rapists, cheaters, conmen, traitors. I am haunted by the thought of the thousands and thousands of unpunished crime that will never be punished, that have been committed in the name of homeland, religion, greed. Anyway, that's the history of the human race. Now, where I wanted to get talking about the evil of humans, the algorithm of social media, call them AI or not, realized that hate and fear are the best strategies to increase the so-called user engagement. User engagement makes money. And therefore, those algorithms keep promoting anything, true or false, that increases hate and fear. That's their job. Algorithms have decided the result of elections, and of course decide daily what we buy and even which movies we watch. So by sowing hate and fear and promoting daily disinformation, algorithms have destroyed families and communities. They are on their way to destroy nations. Algorithms caused the Rohingya massacre in Myanmar. It was caused by an algorithm promoting some disinformation. And it's not only the third world. Algorithms almost destroyed the European Union when they helped Brexit. And maybe they're now destroying democracy in the United States. So in a sense, the algorithms of social media are conducting an experiment on us. That's where I wanted to get. And discovering things about us that we didn't know or didn't want to know. How stupid and evil we are. Or at least how stupid and evil we can be. Not everybody is stupid and evil. The scary thing is not that algorithms do what they do. They do their job. Just like cats chase mice and worms eat dead animals. Nature is not particularly kind. Nature is a horror story. But we can live with that. The scary thing about algorithms is that their job reveals something that we have long ignored. We know very little about ourselves. Even those who study history and neuroscience have trouble truly admitting what humans do. Algorithms don't have to find excuses. And they seem to know us better than we do because they just look at us as we are. The scary thing is that we know a lot less about us than we assume, and we are not prepared to protect ourselves from something that behaves like us on a massive scale, and therefore algorithms can manipulate us with apocalyptic consequences. We know so little about ourselves that algorithms conducting experiments on us can cause devastation among us. And this has already happened. That's why I believe it. Again, Brexit, the election of Donald Trump. There are many, many cases where algorithms determined what happened in a society. What we really learned from AI is that we know a lot less about ourselves than we assumed. At every step of the way, AI has changed our perception of cognitive tasks. What used to be considered difficult turned out to be easy, and vice versa. That's the history of AI. You can read it in my in my book. Lots of lots of philosophers made made assumptions that were just not true. AI easily replicated some aspects of human cognition, but didn't easily replicate others. Anyway, in my book, I spoke at length about the vast algorithmic bureaucracies, and my friends think I'm obsessed with this. So I have to spend 5 minutes in this. What terrifies me is not a future in which machines rule people, but a future in which vast, heartless bureaucracies rule the world, whether they use machines or not. Humanity and compassion are increasingly replaced by a mechanical procedure. It makes no difference whether the mechanical procedure is carried out by humans or machines. Humans, in fact, increasingly behave like machines, which is also the reason why you can easily replace humans. A favorite example is I am sorry. The expression I am sorry is losing its original meaning. When you hear I am sorry from someone, at least in the United States, you know that in reality nobody's sorry. You probably got many letters that started with we are sorry, denying you something you wanted. Nobody in that organization is sorry. And in fact, probably nobody even knows what happened. The letter was sent by an algorithm. We have created highly structured societies in which what is not mandatory is increasingly forbidden. My favorite example, one day, something was wrong with my car. I went to the mechanic. The first thing he asked me to do was to fill a form. Fine. A few days later, a friend broke her wrist while skateboarding, and I took her to the hospital. She was obviously in pain and obviously couldn't write. Nevertheless, the first thing they asked her at the hospital was to fill a form. I filled the form for her and noticed that this form to take care of a wounded human being was quite similar to the form for repairing a malfunctioning car. Enough pessimism. Now let's turn to something else. Let's analyze if the premises of the whole discussion are valid. First of all, we really need a definition of superhuman intelligence. The original computer application that John von Neumann had in mind, John von Neumann is considered the inventor of the computer. Well, not really, but anyway, very smart man. The first major application of computers that he had in mind was a data science project, weather forecasting. Well, none of today's AIs has improved weather forecasting from the way it was 20 years ago. So, reality check. Second, I mentioned that an AI is virtually immortal, ubiquitous, and omnipotent. Because we associate these qualities to the supreme God, we think they are useful qualities. Nature begs to disagree. Nature creates very imperfect beings. Nature creates diversity because diversity has more chances to survive. The reason life survived on this planet is that nature created billions of different organisms. We are the result of millions of years of natural selection. The secret to survival is being able to mutate as circumstances change. I suspect that 8 billion human minds that are all different from each other are more likely to survive than one giant, supreme, monolithic, omniscient, omnipotent mind. The reason humans survived nuclear weapons and climate change so far is that we are 8 billion different brains. One big mind is not subject to natural selection, and it is debatable if it is capable of surviving even the slightest unpredictable event. Third, there are several paths to superintelligent, but as of today, the path is to train AIs on all available data. So what happens when the AI is trained on all possible data? Does AI keep getting more intelligent, or it reaches a plateau of intelligence? This is not clear to me. It is even not clear what happens when, very soon, there will be more machine-generated content than human-generated content. what happens when we train machines on content generated by machines? No, that content might be more reliable or less reliable. I don't know. Finally, what does human intelligence really do? And here I want to spend 5 minutes on a presentation I gave at Stanford and other places. You can find the YouTube videos online. What does human intelligence really do? Deep thinking, not deep learning, is what humans do. There's okay, let's quickly. In my opinion, deep learning is shallow thinking about big data. It needs big data and then it gives you answers. The humanities are deep thinking about small data. We don't know a lot, but we can ask a lot of interesting questions. Think of this 2012 system at Stanford that was able to recognize that there are cats in YouTube videos. Great. But what do we do when we hear that news? Well, first we ask, why are there so many cats on the internet? In fact, some of these videos have 100 million views. Why? It's a natural question. So we start looking at history, which animals have been charismatic in history. And we look at cave paintings, and we look at the Bible. There are actually no cats in the Bible. Automata, actually, there's more automatas for other animals. Cartoons, the most famous cartoon is actually a mouse, which is almost insulting to cats. So why cats? Does it have to do with the unique role of cats in religion, philosophy, entertainment, science? And then you start digging up, oh, well, Egypt had a cat god busted. There was Schrodinger's cat, famous in physics, and so on and so on. Who started it? Well, it turns out the very first video made was a video about cats made by Thomas Edison in person. And the first YouTube video was made by Stephen Chen, one of the founders of YouTube, and it was a cat video. So, this deep thinking, I can go on. And we researchers spend their life studying these things. So that's deep thinking. That's what humans do. Do machines do that? Well, I don't know. To be honest, the closest thing, the thing that really amazed me about generative AI was actually the one thing the scientists didn't like. They hallucinate. When I asked ChatGPT about this obscure black and white silent movie Inhuman, ChatGPT came up with this long story. It's a French science fiction film, and then everything it says is false. So of course I wrote down in red everything that is false about ChatGPT answer, but then I realized, wow, that really sounds like a human being coming up with an answer that doesn't know, and with an answer that's actually very, very, very reliable. So it sounds very reliable. So maybe the real root to human intelligence is the hallucination. Okay, that's a provocative end to my talk.